So now we are going to do the unequal cos. Just now what we done, if you see here in our notes, just now we do the Eigrp equal cos. What we done, we assign one IP 12.0 for the above link, and we have one more link to 21.0. And when we do the configuration, we check in our routing table we both have this root. In our routing table we have two root, that is 12.0, 21.0, because here we have the Eigrp equal cos. Both link are having the equal cos, so it is stored in the routing table. And after that, what we are saying, we will do the unequal cos. Here I use only two router. One I use the fast Ethernet 0x0, another is a Ethernet. In the EVNG we don't have the serial, so if you are doing the lab in EVNG, you can do with fast Ethernet and Ethernet only. But if you want to look the serial also, then you can do that lab in the GNS3. Your wish, concept is important. You can do in packet tracer also. This lab will work in packet tracer, or you can use only fast Ethernet and Ethernet and you can finish your lab. Not necessary you should use the serial also, but anyhow we will use all three, so you will have more clear idea about that one. So this is a basic topology. What I done, I use one router from here, this one C7200, and when we take this one, by default we will have the fast Ethernet port, but here in this router R1 we need fast Ethernet and also we need the Ethernet. Okay, we need Ethernet also. So what I done, I click this one, right click and go in the configuration and go to the slot, and here if you see, this is a 4E means Ethernet, and if you see 4T plus means serial. So I add this one, just you need to click and select from here. You can select any slot, which one you need you can take. Here this is a fast Ethernet, this is a serial, this is a Ethernet. So just I add that one here in this router R1. After that I take this cable, I connect it from here. So this is the fast Ethernet from here to here, this is a Ethernet from here to here, this is a serial from here to here. And in this router, if I check here, I go here in the slot, here I don't have the, here I have the Ethernet, this is a fast Ethernet, I don't have serial. If I need, I can add the serial also. Just keep your mouse, you will get whatever interface you have here, like this. And if you see here, it is showing fast Ethernet. So let me remove this link and add again. So I will delete this one. Now I will again check. So I need the Ethernet, so I will see this is the Ethernet 0x4. I will go here, we have the Ethernet 3x0. So I will take this link. So what I am doing, I am selecting all the category. One is fast Ethernet here to here, another is the Ethernet from here to here, and serial. Why I am using 3? Because I want to check the cost. I want to check that unequal cost load balancing. I need to do unequal cost load balancing. So when we have the unequal cost, we will not have all these three root in our routing table. So I will use some variance parameter to make this all three root come in the routing table. So that we need to do. That's why what I am using here, I am using one as a fast Ethernet, another is a Ethernet, another is a serial. If I use three different interface with the three different bandwidth, then we will have the different cost. So whoever is having that less cost, that guy will come in the routing table, other guy will not come. So for that purpose I taken this. So now let's do the configuration, so you will have the idea. The main thing what we will see here, when we configure the Eigrp, this is a root. Okay, this root we are going to see in the R1, and we are getting this root from this link like this way. Okay, by default it will take this one because this is having the fast bandwidth, high bandwidth. This fast Ethernet is having the high bandwidth, so our traffic will prefer this way to go to this one. If this is not available, then he will take this one. If this is not available, he will take this one. But what we will do, when we check in the topology table, we will have this one also, we will have this one also, we will have this one also. All three will be available in the topology table. But when we are doing the when we are checking in the routing table, we will have only this one. So what we will do, we will add the variance, we will multiply with some number. By multiplying that number, this also come in the routing table. This is also going to come in the routing table, and they will do the unequal cost load balancing. So let's do that one. When we perform this lab, you will have more idea. So let me start the router. So this is a topology already I designed here. Simple, just you need to take and bring the slot and connect as we are doing before. And after that I will take the console of this one. So let me take the console of R1 here, and then console of R2. Let me go here. Let me close these old routers. So this is the console of R1 is working, I think. So now let me take the console of R2. Console of R2 also okay. Now we will take the console of R3. And now we will take the console of R4. So console of R4 also ready here. What we need? Console of R5. Just I am opening the console in the sequential order, so easy for us to copy paste the configuration. So this is also good, and I think we don't have any configuration. If I write show IP interface brief, we don't have any IP address. If we check show IP root, we don't have anything here. So we need to do the configuration from the scratch. So I will take this notepad, I will write here Eigrp Unequal cost lab. So here I will write the R1 configuration, enable config T, host name R1. After that we have the interface fast Ethernet 0x0. So we will write IP address. As we write IP schema here, same we will use 12.1, 255.255.255.0, and then we will write no shut here. And then I will copy this 3 times because we have 3 interface. So I will copy this 3 times and I will paste here, and we will modify. Second one is E4/0. So I will make this as a E4/0, and here what is our IP schema here? If you see 192.168.13.1, so this will be 13.1. Sorry, this one. This will be 13.1 E4/0, and this will be S3/0. So I will move here S3/0. Okay, S3/0. This one. This will be 14.1. Okay. Just I assign the IP address. What I am doing? Fast Ethernet 0/0 12.1, Ethernet 4/0 13.1, Ethernet we don't have Ethernet, serial 3/0 14.1. Just we assign the IP address. Now we can enable the EIGRP. So we can write router EIGRP1, then network. For lab purpose we can use this 0.0.0 this command. So I enable the EIGRP in all active interface with this command, but don't use this in the production network. Okay, this is only in the lab purpose we will use this command. So this is the R1 configuration. Now we need to do the R2 configuration. So what I will do, I will copy this whole thing, I will paste here, and we will modify here. This is a R2 and this is a R2, and in R2 we have only one interface, fast Ethernet 0/0, that is a 12.2, this one. And if you see 1/0, so we don't have this here, and this will be, we have F1/0, this one. And if you see here we have 192.168.25. So this is a 25 dot, we will write 2, whatever the router number that we will write dot. So this is a 2, so 192.168.25.2. Okay, so this is the interface. This router is having this interface, so we assign the IP to this 2 interface. After that we have the EIGRP configuration. With this command it will enable in all the interface. So this is the R2 configuration finished. Let me copy this whole thing and I will paste again here. This is a R3, and here also R3. Okay, R3 configuration we are doing. R3 is having E3/0, so I will go here, I will write here E3/0. Okay, and here 192.168.13, 13.3. This is 13, this is 13.3, this one E3/0, and we have F1/0. This is a F1/0, and this is 26. So we will make this 26 dot 3. Why dot 3? Because this router number we are taking, this one 192.168.26.3, and this remains same, and this also remains same. This is a R3 configuration, so this is good. I will copy this whole thing from here to here and I will paste, so we can do for the R4 configuration. So this is a R4 here, and this is also R4 here. This is a R4. Okay, so this interface is serial. This I will make as a serial S3 by 0, and we will have 14. This is a 14.4. Why 4? 4 router number we are adding. So 14.4 this one, and then we have fast Ethernet 0 by 0 here. Fast Ethernet 0 by 0. Let me correct here. Fast Ethernet 0 by 0. 192.168.27. This will be 27 here. 27 dot. What is the router number? 4. So 27.4. So this is a R4 configuration. Everything is good here, no issue. Now we will write for the R5. So R5 is having 3 interface, so I will copy the R1 configuration. So this will work for R5. We can make some modification here. So let me go here, I will paste here, and we will put, this is the R5, and I can move here and we can check. R5 is having fast Ethernet 0 by 0, and what is the IP? 192.168.25.5. so this will be 25.5, this one, first IP. Second is fast Ethernet 1 by 0, so I will make, this is a fast Ethernet 1 by 0. What is the IP? 26.5, so I will make this as a 26.5. and then we have fast Ethernet 2 by 0, so this will be, I will change this fast Ethernet 2/0, and IP will be 27.5, so I will write this as a 27.5. No dots, right? Till here whatever we done, and these two command we used to run the routing protocol. Eigrp will be work on the all interface, whatever is the active interface. So this is the just configuration. Let me save. Sometime we will have issues, so we will lose the configuration. Better let me save this configuration. Okay, so let me save this configuration. Now I will copy and paste in R1. One by one we will copy and paste. So let's see in the R1. I am not sure, maybe some spelling mistake or anything. Let's try one by one. If any issue, we will correct that one. So let me paste here. Everything is good, no issue, nothing, no spelling mistake, nothing. Everything is good for R1. Now I will take the R2 configuration. I will copy from here to here, and I will go here. Let me check, someone write something. We need to configure loopback. Yeah, correct. I forget the loopback, so let me write the loopback here. Thank you. Interface loopback. I wrote loopback 0, I think. Loopback 0 IP address 5.5.5.5, then 255.0.0.0. Okay, this one loopback 5. So let me correct this one. We told loopback 5, this one. Okay, so now I will copy this R2 configuration from here to here. Everything is okay. Let's go and paste in the R2 here. Let me paste here. R2 is also good, no dots, no error here. Everything is good in R2. Now I will copy the R3. So here I will take from here to here will be R3. I will copy this one. I will paste in the R3. So let me press enter, and then paste the R3 configuration here. So R3, I think R3 will be okay, no dots here, no error, everything is good. Now what we will do, we will go for the R4, and then I will copy the R4 also here. I will take from here to here R4, and then here just press enter, and then I will paste the R4 here. Okay, R4 is okay here. Now I will go for R5, and let me take the R5 configuration. I will copy this, and I will take this, and I will paste here R5 configuration. So R5 also okay, no doubts here, nothing, everything is good, I hope. So let me check here. This is good. Now we can check here in the R1. When we write here show IP route, we are getting the route here, or let me write here show IP route Eigrp. Okay, so if you see here, we are getting this route from the Eigrp. This is the route, but what I wrote, show IP route Eigrp. So it will show only Eigrp route. So 1, 2, 3, 4 routes we are getting from Eigrp. But if you see here, if we want to go to 5.0.0.0/8, that is 5.5.5.5 network, we have only one route, that is 192.168.12.2. If you see here, which one we have, 12.2, this one, only this one. We can go from here only. This is also there, but this is not showing in the routing table. This is also there, this is also not showing in the routing table. Why it is not showing? Because it is having the high cost. Because the fast Ethernet is having the good bandwidth compared to Ethernet and serial. This is having low, this is also having low, this is having high. So this route is coming in the routing table, this one is not coming, this one is not coming in the routing table. And if you see here in the topology table, we will have all, but in the routing table we will have only that one, show IP Eigrp topology, not traffic, show IP Eigrp show IP Eigrp topology table. If we see in the topology table, we have all. If we check here, where is the 5 network, this one. If you want to go here, we have this one, we have this one, we have this one, we have all. But if you see, we have different here. If you see, we have different here. Okay, this is the serial. Serial is having the high, then Ethernet, this is also high. If you see, this one is a low. So this one they are preferring. This cost is low, this cost is high, little high, this one is very high. So for that purpose, he is taking only this one. He is not taking this one, not taking this one. But in the topology table, they will have all the path. If this go down, they will bring this in the routing table. But now all these routes are available, but they will put best one in the routing table. So now we need to bring all this. We need to do load balancing with all these three. So what we will do, we have one method we need to do. We need to multiply with the variance. What is variance means? Let me show you in our notes. Let me show you here what we done here. Here we use only two router. This is a fast Ethernet and Ethernet. We did not use serial because I performed this lab in the EVNG. In EVNG we don't have serial. So what I done here, I configure, and when we check in the routing table, if you see in the routing table, we have only one route. We are getting only one route. To get the other route, we need to multiply with the variance. So how we will get variance? Variance is nothing but the feasible distance divided by this cost. So simple, we need to divide. We need to divide this one, this value with the feasible distance, and whatever number we are getting, when we divide, example 412160, this one I am dividing with this value 158720. When I divide this one, this is a feasible distance. When I divide by this reported distance, whatever value we are getting, example I am getting 2.59, so round off we will take as a 3. We need to go inside the router Eigrp1, and then we will write variance and 3. So they will multiply, they will divide this number, and they will make this to come in the routing table. So if you see here, when we write show IP protocol, we are getting here maximum matrix variance is 1 before multiplying. When we multiply and when we add this one, when we do variance 3, we will have that route, and when we check, it is saying the variance 3. So this way we can bring the unequal cost route in our routing table. Let me repeat again what I am saying here. Let me repeat here. I am saying here, when I check the topology table, I know that to go to this network, I have 3 routes, 12.2, 13.3, 14.4. But they have different costs because we are using fast Ethernet, Ethernet serial. If we are using fast Ethernet for all 3, automatically they will come inside the routing table because they have the equal cost. But they have different costs here. That's why this Ethernet and serial will not come. If you want to bring, example, if you want to bring the Ethernet, what we will do, we will take this number 412,160. Okay, we will take this number, we will divide with this one, feasible distance 158720. so when we divide whatever number we will have, that we need to put as a variant. So we will check here. Let me take calculator. This is a method we need to follow when we want to bring the unequal cost in the routing table. When we want to do the unequal cost, what we can say, load balancing, we need to use this method. So what I will do here, I know here this number, so I will write here 4141, this one 2160, and then divide by feasible distance, this feasible distance 15158, this one I am saying 158,720, and what number we are getting, 2.5. so around 2.599 like this. So I will take around like 3. So if I want to bring, example, if I want to bring this route in my routing table, I need to increase the variant as a 3. If you want to check currently what is the variant, show IP protocol, when we write this one, you will see variance, maximum metric variance is 1. So if we increase this variance, depending upon after dividing this number, this route will come automatically in the routing table. Now if we check here in the routing table, what we have, show IP route Eigrp. If you see, we don't have, we have only one route. This is to go to this network, we have only one route, this one only. But now I want to bring this one also, the Ethernet one, this one. So what I need to do, just now we divide this number with this one, so what we get, 2.5 something. So 3 we can take. So I will go here, I will go in the global configuration mode, I will write router Eigrp1 and then variance and put question mark. Here you have the option, you can write from 1 to 128, but now we need to use only 3. So I will write here 3. So just I say, I give variance as a 3, so they will recalculate and then they will change in the routing table. So now we can check show IP route Eigrp, and if you see, now we have this second route also coming. This is the first route 12.2. before we are having this already, but Ethernet is not having, this one is not having. Now we have this one in our routing table. This is a 192.168.13.3. before we don't have. If you see here where we check just now, here you have only one route here, this one, from the fast Ethernet 0/0. But after doing the variance multiplier, when we write the variance multiplier, just we need to multiply, we need to write variance and we need to write that multiplier number. So automatically they will recalculate and they will bring that in the routing table. So this route came here. So now we are happy, we will say okay, we will do load balancing with this too, but not 100%. They will do like here will be 50%, here will be 60%, like that. So now example, if I want to bring another one also, example, let's see here, I want to bring this one. Okay, which one? Serial one. Where is the serial one? Let me check in the topology table. This where is topology table? This is topology table. So if I want to bring this one, imagine I want to bring this also in my routing table. So I need this number from here to here, this number need to multiply with feasible distance. So what I can do, I can go in the calculator. Here I can delete everything. If I can paste here, let me, this number I taken 2300416, I will divide this and then I will write this one 15158,720 and is equal to, you have 14 point something, we can take as a 15, okay, or we can take as 14.49 or we can take 15. So what we will do, to bring that one, we need to go inside the configuration, router Eigrp1 variance 15, I will write 15. So now we will check, we will have the other also in our routing table, show IP route Eigrp. If you see, we get here What we get? This one, this one, this one. To send any packet, we will have this one, this one, this one. All three will come. By default, it will not come because they are having different costs. Whoever is having equal, that will come in the routing table. But with the help of variance multiplier, we can bring that route in the routing table. How we bring? Just we divide that number with the feasible distance, and whatever multiplier is getting, we need to go in the Eigrp and just write variance and that number. By writing that number, it will come in our routing table. So now we have this route, this route, this route. All three routes come in the routing table. If you see here, in our notes I wrote all this theory. If you see here, this is a configuration. Let me show you. Yeah, this is a configuration, and here enter in Eigrp routing mode and set the variance 3 to install the other route. First one. If you want to install the other route, that is the serial one also, then you will put here 15. All other configuration remains same. Here what we done, we write no auto summary, but new version, even if you did not write this no auto summary, it will work. So when we check, we have having only one route here, and after doing the variance calculation, when we done, we divide this number with this one, so we have the other route here. We get 3, and when we put 3, we have the variance matrix is 1. If you want to check variance matrix, we can check show IP protocol. You will have the variance matrix is 15 because we just now we changed that one. Okay, and what else we can do here? We can this one we increase, and when we check, we have this 2 route. I use only here 2 because we don't have serial in the what we can say in the EVNG. But here in the GNS3 we have serial also. For that one I done here in the serial also. And what else we can do here? Let's see, where is the putty here. This is the R1. So we have show IP Eigrp topology. Topology will show all that one. And what else we have here? Show IP Eigrp. Let me check here what else command we can see. Events, topology, traffic. Let's see the traffic. This is the traffic. Normally we will see hello packets, how many hello packets came and go. This we checked yesterday already. We have one more command. I think with that one I can check the share one also. Show IP Eigrp neighbor interface event accounting timer topology traffic. Maybe this, let me check here. Maybe that command is in the real router, not in this one. Anyhow, let me cross check. Here we have one command. With that one I think we can check the whatever what we can say the load also, how much load it is sharing, like that. Somewhere we have here, let me write here show IP Eigrp timer is not that one. And if we go for the other one command is there, I did not remember, show IP or maybe packet something. But anyhow, with this one we can confirm. With this one, when we check here, show IP route Eigrp, with this one we confirm, we bring that one. And we have one more, like we can check how much load is going for serial Ethernet, fast Ethernet. We have something like that one also. Or let me check with the interface command, show IP Eigrp interface. Here it is saying that not this one, traffic or packet or something like show IP Eigrp traffic. This one we checked just now, right? This is a traffic, show IP Eigrp neighbor detail, not this command also. Neighbor, we have neighbor detail, we have the serial interface. Or topology we check, traffic we check, Eigrp show IP route, Eigrp also we check. I think this is only the command, but we have maybe in the OSPF we have, because when we write show Eigrp in this router it is not showing events. We have accounting. Let me check accounting. Maybe no, not this one. Show IP Eigrp. With that one it is showing how much load they are sharing. Accounting, events, interface, neighbor, timer, topology, traffic we checked just now. It is anyhow no issue. So as we are saying, we will have the one command. We will write show. Let me show you here. Show IP root, and we will write 5.5.5.5 to go to 5.5.5.5. how much they will use. As we are saying that one, we have 3 path now. So if you see here, for serial they will do the 17%, for Ethernet they will do the 92%, but for the fast Ethernet they will do the 240%. Means share count. If you see, this is a traffic share count. So we use this command just to confirm, just to cross check. If we are saying that, first of all, what we are saying, why we are doing this lab. First of all, we are saying Eigrp is supporting equal cos and unequal cos. Okay, unequal cos. Equal cos means all interface is having the same interface. Like if we are using the fast Ethernet, all interface will be fast Ethernet. Then we will say that is the equal cos. Automatically that will come in our routing table. Directly that will come in our routing table. So no worry for this one. But for the unequal cos, we will multiply with the variant. We will multiply with the variant. When we multiply with the variant, unequal cos also going to come in the routing table, and they are going to do the load balancing. But they will not do 50-50%, means they will not do 100% load balancing. They will do like 30%, 17% like that. So if you see here, this is a fast Ethernet. So traffic share count is 240. So 240 this fast Ethernet is doing. But Ethernet is doing 92%. If you see, serial interface is doing 17%. So they are not doing equal cost load balancing. They are not doing equal cost load balancing, but anyhow they are doing some load balancing. Even if they have unequal cost, they are doing the load balancing, but not equally. They are doing unequally load balancing. So with this command we can check. Write the destination IP, write show IP root, then write the destination IP. We have destination is 5.5.5. So what we are getting here, if you see here, we are getting here 240 for the fast Ethernet we are getting 92, and for the serial we are getting the 17. And if you are using the same interface for all, and when you check this way, you will have here 1, here 1, here 1, like that, if they are using the equal cost load balancing. But here we are using unequal cost load balancing, that's why we have different value here. Fast Ethernet is using 240, he is doing 92%, he is doing 17%. Okay, so with this way we can say Eigrp can do the unequal load balancing also. And how manually they will automatically they will not do. We need to multiply with the variant. And how we will calculate the variant? Just we need to look this one, and this visible distance we need to multiply with this one. When you have the one numerical value, that numerical value you need to put as a multiplier here, variance multiplier. So automatically that root will come in the routing table. Okay, and how we will check? We will check with this one. Just we need to write show. Let me show you. If you want to cross check also, you write show IP root and write the destination IP. You will get how many percent they are doing they are sharing the traffic load. Here 240, here 92, and here 17. Okay, and if you want to trace route also, you can use this also, trace route. So here they are going from 14.4. If you do again, here it is 14.4, 27.5. They are using here again, if you see 27.5, 26.5, and if you check again, they will do again 13.3, 26.5. Again they will do same, again they will do same. They are not doing equally, they are doing unequally. Here if you see 26.5, if you see 26.5, here 13.3, and somewhere you have some different also. Let's see where is the different. This is 27.5, here is 27.5, you have 14.4. so they are doing unequally. Okay, so this way we can do unequal cost load balancing. Let me stop